Hi there, I'm Hao. This is just another video of me solving random number problem. So today you need to find the next permutation. So assuming you're already familiar with permutation, right? So given an array, permutation in how many ways we can arrange that numbers, right? Order does matter. So you have 1, 2, 3. You can also do 1, 3, 2, right? 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1, 1. So C combination. So um they want us to find like the next permutation, which which means that the next bigger number, right? So 1, 2, 3, the next bigger number is 1, 3, 2, right? 3, 2, 1, the next bigger number is 2, 1, 2. And if it's the biggest number, right, then we want to go back to the beginning, which is 1, 2, 3. Right. So the naive approach we can do, which is we can just find all possible permutation, right? We take as like n factorial time complexity, right? And we need to store them, right? Um, so that is ON space, which is not very efficient here. So instead, we can do it in ON's time and O1 space. So let's look at this example right here, right? So if we start from the right side and iterate to the left, we can first, find the um, first we can find the um, non-decrease index, right? So 3, 4, 5, they are increasing. So the first non-decreasing index would be at 2, right? Because 2 is smaller than 5. So which is this guy right here, 2. So index 1, right? And then from here, we can iterate back to the right and find the number that is, so we're gonna find the minimum number, right? Mean, or other words, it's just the next larger number, right? Next larger number from index, right? In 1, right? In 1. Um, so in other words, we have to find the number, the minimum number that is larger than the value at index 1, right? Right. So we can just keep iterating if 5 is larger because we know that we are looking for the first decreasing element, right? It means that from the index 1 plus 1 like to the end, we know that the array is sorted, right, in decreasing order because we are looking for the first decreasing element. So everything on the right is sorted in the descending order, right? So as long as we find a number that is larger than 2, we just gonna keep going, right? Because we know that they are sorted, okay? So we can iterate this way, and as long as we find a larger number, we just keep going, right? And we're gonna stop at 3 because here we don't find anything. That's right. And so what we're gonna do is we're gonna swap them. So remember our original number is 1, 2, 5, 4, 3, right? We can swap them. This become 3. This become 2, right? So after we swap them, um, we will reverse the remaining array, right? From this index plus 1, right? So we're gonna have 2, 4, 5 instead, right? And as you can see, 1, 2, 5, 4, 3, right? The next larger number is 1, 3, 2, 4, 5, right? We are at the 2000, right? the 2000, right? So the next, larger would be the the 3K, right? And we had to reverse this to get the smaller number of the new 1000, right? So yeah, again, the first step is to find the first non-decreasing number or the index, right? And from that index to the right, we need to find the next larger number, right? A number that is larger than the number at this index, but it has to be the minimum, right? And then we can reverse the remaining array, right? So what happens if we cannot find a decreasing element? Let's say we have five, sorry, we have five, four, uh, four here, three, two, and then one, right? We cannot find the decreasing element, right? And we reach like the end of the array. So in that case, we know that it is the biggest possible number because they are in reverse order, right? So we can just reverse the whole array. One, two, three, four, five, right? So that is the strategy. Let's code this up. So we will need a first of all we will need a helper function, right? To reverse or to swap, right? We need like the one function for swap, back in x1, in x2. So the swap here is when we want to reverse the array, right? So 10 num of index I, right? Nums at next one equal to nums at index two, and nums at index two is 10, right? And we need to be able to reverse the array, inverse, right? We're gonna check in the left and the right index. We reverse from in a certain the certain subarray, right? So y left is left and right, and we want to swap left and right, and we want to move to the left and move to the right, right? You just keep swapping until left and the right overlap. Okay, so that is the left and the right. And the next thing we have to do is we need to find the first decrease on index. Uh, find first decreasing index. Find the first decreasing index. Yeah. No. Uh, okay. So we're gonna start from the end, right? Which is 4 equal to number of 9 minus 2, because we want to look at the next number. I greater than or equal to 0. I minus minus. So if nums of I is less than, right? Nums of I plus 1. The number of I is a number on the left. And nums of I plus 1 is a number on the right. If it is smaller, then we want to return I, right? If we cannot find anything, right? Everything is increasing from right to left, then we just need to return it. Okay. So we're gonna have two cases here, remember? So if the first degree index equal to it's not null, right? The second case is when it is null. So if it is null, um, we know that the array is sorted in decreasing order. So we just want to reverse the whole array, right? So you can call reverse, passing in nums of 1 minus 1. We reverse the whole array, right? Otherwise, you're gonna find the next larger number and swap them. So I can say swap index is equal to first degree index plus 1, right? And y nums of swap index plus 1 is greater than num at the first decreasing index, right? We just like increase the swap index. right? So um, the first decreasing index here will be, uh, right, let me look at the other example here. Right, so before we even reverse, uh, yeah, so here, it is our first non-decreasing index, right? So we find the next larger number by looking at the next number, right, to the end. And as long as we find a larger number, we just keep uh, increasing the swap index, right? We're looking at the swap index plus one, right? So that we can stop one before because we want to reduce the swap index. Okay, so that is that. Um, so after we find the next larger number, we want to swap swap the swap index with the first decrease index, right? And we want to reverse the first decreasing index plus one to remove the all. All right, this is accepted, and thank you for watching.